It's fun time. Welcome, welcome, welcome to Amberskies. My name's Blades, and we have not got computers started. Alright, okay, that's fine. Oh dear, let me just settle down, grab me coffee. I was running a bit late today. I was messing around with Git. So, starting to set up the GitHub. Let's find out what I was doing. Alright, here we are. Start up a computer. Can't see why not. Oh, are you ready? It's cold. It is, it's cool, it's cold. I've got these lovely computers warming me up. It's not throwing out enough heat, I don't think. God damn it. Never mind, never mind. It's going well. We have OpenGL now working on a computer, a fictional computer, which is just loading up here. Completely virtual computer, no hardware, and we have OpenGL working on it. This brings me to what I want to start with today, which is probably a rant. If I can do this without a graphics card, why are we suffering Windows 10? Think about it. Windows 10 is rubbish. Let's get an application from Windows 10. Have I got one here? Yeah, here we go. Windows 10 application. There you go. That is what a Windows 10 application looks like. Interesting. Yes. Right, well, that's wonderfully deep. Depth. There's no 3D to it at all. There's nothing. It's just very, very basic programming. All of this, there's nothing to it. Look, we can do that just by clicking a button on here. We can create better than that. I mean, this isn't even set up for 3D. And last session, yeah, here we go. Look at that button here. It's actually got, it's not great, but it's got a little bit of something to it. It's got a button type look to it. Interesting. Very, very interesting. What is going on? I have no idea. It's a rant that I have a lot of. Windows 10 is so flat. It's stupid. I mean, the icons have more 3D than the I mean, I've got an icon here. Let's have a look at this icon. Oh, we can't look at the icon. Where's the icon? There we go. Look at that icon. That's more 3D than Windows. And that's just it with a plain drawing with shading on, shadows being placed on the drawing. There's nothing like that going on in Windows. It's crazy. Anyway, Microsoft, you owe us a rebate for the last 20 years. 25 years of Windows it's going to be next year. And they have done nothing. Nothing in 25 years. If you go and look at Windows 3, 3.1, 3.3, and you look at what we've got today, we've got the same program. They've done nothing in 25 years. They've progressed nowhere. Nothing visually, nothing to help the user. It's the same program. Sorry, Microsoft. You failed. You failed badly. I want to develop something better. Which is why I started with that launcher. I've been messing around with Git commands. Changing the subject quickly. No, it's not there. I do have one of these, don't I? Yeah, I do. Whiz. Here we go. Password, yes. You are storing passwords for me. I remember now. Thank you. GitHub. Do I really need to do that? I don't know. Can I not just put in www.github/Amberskies? Am I allowed to do that? Site can't be reached. Well, it's HTTPS for starters. Can't be reached. github.com. Ah, there we go. There I am, Fraser Sharp, Amberskies. Yeah, so I can do that. github.com, Amberskies. There we are. I've been messing around trying to get this started up, and not sure what workflows are, but what I've done is, that's the master. I want development, please. Thank you. I haven't sorted out what I want to put on the master yet. This is just me messing about at the moment. As you can see, I've decided on 3 static libraries that I want to make. One network, the core library, and a 3D library for 3D stuff. So yeah, that's coming along, and I think next week we might start doing stuff with that. Only thing I'm not sure about on here, click on that a minute. Does it tell me if they are public or not? It doesn't seem to. I can see this, and I'm not signed in. So I guess it's public. I don't know. I don't know. How can you tell with things like this? I have no idea. Anyway, in the meantime, let's get back to some coding. Let's get this sorted out, because what we have now is 2 shaders. That's from yesterday, so we actually didn't do too badly. We got something together that will load a shader. OpenGL. Here we go. Let's get rid of you. PaintGL. We're going to need an object to paint. That's a definite. Let's see if we can make one. I don't want anything complicated. So yeah, it's going to be a triangle, isn't it? What do we actually need? Well, the only input we've got is 1. We've only got 1 input to this shader, and that's vec3 position. So let's make some positions. Alright, yeah. So that's all we're going to need. So we'll make some vertices. I'll call them verts. Why not? First thing though is that I will want to store where we're going to send the verts to. So let's do that first. How do we do that? We can have an int private. So I've got all of this lot. That's what we did yesterday. So I'll leave an extra space. I'll put an int position. Yeah, okay. M underscore position. Right, yeah, we'll have that. Save. Here, M underscore position equals something. What will it equal? Well, it'll equal our M shader program. M underscore shader program. And it's going to be attribute location. Attribute location. And we need the name. Position. Okay, that'll do. That's all I need. So that saves. M shader program is the handle to the program on the graphics card. That program on the graphics card has inputs, and for each input it will have a location, and all we need to do is take that location and store it so we can use it later, so we can send our data to it. That sounds good. Let's do that. Anything else I need to do here? We did the link, didn't we? Ooh, wait a minute. I think we missed something. Shaders H we're using, are we? Yeah. Local program. We did miss out something, and we just needed to bind it so we can use it. Yeah, I think we'll do that. We've only got one program, so we'll bind it here. And that will be happy joys. It does need to be bound if we are to do that line there. So that program needs to be bound. So I'm just wondering, should I put it inside or outside? Inside, I don't really care at this point. Yeah, that'll be fine. So that's our shader finished. Now we'll take some floating point positions. So graphics library float, maybe. Yeah, we have them. Good. GL float. I'll call them verts because I usually do. And we'll set these equal to something. What shall we set them equal to? Semicolon, please. Let's see. 0th vert, or the first vert. And have I got this up? 0.5. Yeah, okay. X, Y, Z. So let's set it up. X, Y, -1. How many of these do I want? Four. Let's do 4. Yeah. Now remember that white space in C++ doesn't mean anything. So by hitting return here, I'm still on the same line. Okay, there's 4 of them. Oh, don't need the last comma. So that is a single line of vertices. So they're held in a long line going across. Yeah. People don't seem to realise that. It's just because I format them out like this doesn't mean they're in 3s, X, Y, Zs. It just means the numbers. There's no X, Y, Z. The computer doesn't know that. That's just my mind working, not the computer working. So, yeah, these verts aren't going to hold very long, are they? Don't need to, do they? We're going to put them onto the graphics card. So that's fine. Better change a couple as well. I'll -5 on that. I'll minus 0.5 on that. And I'll do it to both of them on this one. See what happens. That should do, shouldn't it? Really? Too many. Bring you back one. There we go, that all lines up now, doesn't it? That's lovely. Okay, we've got some verts. Hey, we're happy. Now we get some different types of variables required, I guess. In modern day OpenGL, what do we need? We need a vertex array object. That's the title of the object. So, vertex array object. Now, what this is a recorder. It's a recording object. It records what you do next. Yeah. Like a macro recorder would do when for doing buttons. If you downloaded a macro recorder for you know, playing games, you wanted a macro to go off, so it did a sequence of buttons or something. People say that's cheating in games. Other people say, well, it's available. Why not use it? Two minds on that one. It's cheating. Because you're not playing the game. All you're doing is programming the computer to play the game for you. Sorry, but that's true. Right, so we are going to have an OpenGL vertex array object. Right, okay. How do we get one of them? Well, we go over to here, and I will add a queue. No, I won't. We'll go up here. This is going to get ridiculous on the includes, isn't it? Hash include queue OpenGL. And it's a vertex array object, please. There we go. That one. One of them. That's what we want. What should we call it? What is it? M underscore test object. Because that's what it is. Right, okay. Which means it's got a star on it. Go back to the top. Go here, comma. Test object is a null pointer. Because we haven't set it. Alrighty. Okay. Lovely. That's working alright. So we'll need a new one, won't we? Well, we don't really have a new one. Just thinking how to do this. Do we need to put it as new? Did I do that with the shaders? Yeah, I did. Is that line needed? Awkward. I am not sure. Do we actually have to state that it's a new one? It does have a queue object parent. And we do have a queue object. We can make it a parent. Alright. This goes into how it works a little bit better. Encapsulates the state needed to specify per vertex attribute data, blah 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 blah. Very complicated worded. Basically it just records what you do next. There's nothing saying here that we need to use new on it, although I think we should. I don't normally. Oh well, I don't normally. That'll do me. Or do I? Hey notes. What do you think? I'm going to take you. Copy. I am going to put you in. So we're going to have a new. I think it needs. Does it need anything? Can't we just do that? I mean, that's allowable. No. I'll take all that lot out. Don't need it. It'll work with that. That'll give us the base, or basic version of it. So yeah, we'll have a new one. Why not? And here, all we now need to do is put m_test object. Create might help. That's why I was thinking to myself, do we really need to add new? Well, we should do, because it's a pointer is the answer. So now we've created it, we just bind it, I suppose. Set it working. Right, it will now record whatever we do, interestingly. So what do I want it to record? Our vertex buffers. Yeah. So this is what we want it to record. Vertex buffer objects. So what is a vertex array object? It's just the title. Call it menu. And then below the menu you get a list of dishes if you're in a cafe, which we are going to call vertex buffer objects, and each of these are going to be recorded by our array object until we say otherwise. We're going to need a position buffer. Right. Okay. Let's have a position buffer. Start up here to hash include. I should actually do these as separate, because this is a separate day, isn't it? Okay, hash include. Q open GLO buffer. Yeah, I think we'll have that. We're going to have one. Whoops, that was bad news. Didn't want to do that. Control Z. What's going on? Okay, I've just destroyed everything. Right, okay. Do not save. I'll just reopen it. Alright, I'll just put space there and then just messed everything up. Include. I don't like, well, I'm not sure I like this open GL buffer. This kind of goes a bit weird on me sometimes. Mind you, it's my hands doing not exactly what I want at times, so I have problems using my hands. Okay, alright, I'll admit it. This is going to be position buffer, isn't it? So m_position buffer. There we go, that'll do nicely. Again, let's make it a new one. So Control S, save out. up to the top. We'll have a new one of these now. I want to specify the type, don't I? So that's going to be a new QOpen GL buffer. Is it going to tell us? It's 1 of 3. Right, that's the one I wanted. QOpen GL buffer : Okay. Type QOpen GL buffer, which is that one, : type. Vertex? I can't remember how they did this. Yeah. I think that's right. Vertex buffer, index buffer, pixel pack buffer, pixel unpack buffer. Right, well I just want to differentiate between the first two. That's all. So yeah, I'll do it that way, because that tells me what I've got. Alright, okay. So I now have an object. So what we have to do is create our record of it. So underscore position buffer. We want to create it. Underscore position buffer. What else do we want to do? Bind it. And then we should underscore position buffer. We should really allocate the data, which is our verts. And of course we need to tell it the size, size of that one, is it? Yeah, size of verts. Why is it doing it like that? Don't know. Okay. So we've created it and we've placed our data into the location that has been created on our graphics card. So what is happening here is we are allocating space on, we are creating a location or a variable that says this is the location of your vertex buffer. We are then binding so we know what we're looking at, because we could be bound to a different thing by accident. And then once we're bound and the graphics card is said, hey, this is what we're looking at, we are then sending the data to that position that we've created. So all the data then goes in there. And it knows the size and it works it all out. It goes onto the graphics card, puts your data there, and everybody's very, very happy. But we also need to record what that data is. Because remember, that's just a long string of numbers. Doesn't mean anything. So what we're going to do is underscore program, shader program, sorry. And we are going to enable the attribute array. And it says int location. Well, we already know that. That's position. There we go. Just like that. And Then we need to tell it. Okay. We've now tied up that we're now saying to the graphics card, hey look, that data that we have sent you here goes into the shader here with this shader program. Okay. It's going to use this shader program, and we're going to ask you to send that data to that position, which we have got here. Okay, but that's a vec3, and that's a vec4, so we can have different sizes. Ah, that's confusing. Computer hasn't got a well, we don't know, do we? So let's tell it. Let's tell it all about that. So let's get our shader program up and just say, look, set the attribute buffer, which is the buffer that for these attributes here, that's going to be using our data here. Set this buffer up so that we are using m_position. Okay. That they are GL floats. Okay, GL_float, please. We'll do a lot better. There we go. Thank you. Change its colour. Right, good. Now it needs to know the offset. There isn't any. How many how many of these are to be used per transfer? 3. So I use them 3 at a time, X, Y, and Z. Because we said vec3. If I put the extra Z number in, by the way, I can. I could put comma. I think it was 1, wasn't it, we used? So you can actually do that. You can put 4 numbers here, and that becomes a 4. Or does it? Int tuple size. Yeah, 3. And the stride. It's null. It's continuous. It's int. You don't need to put this in. Okay, so it won't. It's not needed. There you go. So all we've done is tell it, begin at the beginning, and use them in 3s. So, yeah, I think that's correct. Let's have a look, see if I've actually said it correct. Components per vertex, 1, 2, 3, or 4. There you go. That's what tuple size is. Tuple size. Tuple. Thank you. Tuple size. Memory's gone correct now. Indicates the number of components per vertex. 1, 2, 3. Yeah. It's mind-blowing, isn't it? But they just give it complicated names. So we're telling it that we want that data to be used for that variable in here. Three at a time. Everything matches up. Everything has to match up. Position, the word there has to be spelt exactly the same as position there. In fact, I would normally advise that this is where copy and paste could save you a headache. Copy and paste if need be to make sure that you've got the same exact spelling. For me, it's critical. I'm dyslexic, so it's critical that I double check everything like that. So yeah, as you've seen before, me go into dyslexia mode and just type something completely weird on the screen, which is exactly what my brain thought I was supposed to be typing. It's a bit embarrassing actually, but well, hell, it's part of my life and it's what I am, so I don't mind. And that's everything we need to record. We've now told it that we have a buffer of data Okay, so we've used our verts here. There you go. Verts are we've used here. So all of our data will now be used in this way. That's brilliant. That's absolutely fantastic. Is there anything else we need? No. That's the end of our program, or recording, because I told you it was a simplified one, didn't I? To draw an object on the screen, all I need is, oh God, yes, we do need something else. Whoops. Just realised what I've done. I'm drawing a square. That's 2 triangles. Yeah. We shall do the next. We'll add an extra set of data. We will have a GLUint. I'm glad I remembered this. Index. And that's going to equal the following. Semicolon at the end, and let's put in an index. We'll have 0, comma, 1, comma, 2, comma, that's your first triangle, 2, comma, 3, comma, and back to the 0. I think I did them in the right order, so we can do that. Okay, if you're wondering what the 0, 1, 2, and 3 stand for, they are here. 0, 1, put a space in so it looks better. 2, and 3, and that is your is that right? Yeah, index. There you go. There's your index numbers. So that is the 0th vert. The first vert, second vert, and third vert. You use 3 of these to make a triangle. Okay, we have to use triangles to do OpenGL. So you put those points on the screen, 0, 1, and 2. If you plot those on a graph, ignoring the last column, you will get a triangle. So that plus that plus that, it makes a triangle. Also, 2, 2, 3, 2, 3, back to the 0th makes another triangle. So those 2 triangles, when you put them together, should make a square. I hope. But now we have to record that we've done that. So we are going to need an index buffer, which is just another OpenGL buffer. Copy and paste, and we'll call this the index buffer because we can. I just realised this is turning out to be a lesson in OpenGL on Qt, which is not exactly the intended outcome, but it's worth doing properly. Put a comma on there, hit return, V, and it's that lot there. And it's just capital I index buffer. There we go. And I need an extra Dubry. Thank you. That gives us an index buffer. Yeah. we have some index numbers. What this does is tells our graphics card in which order should it use our data. Yeah, that's all it does. So let's have an index buffer object. So may as well do it properly. Index buffer object. And this gets recorded by the vertex array object that we're doing this. Okay, yeah, do it properly. Right, so our index buffer. Guess what we're going to do? Underscore index buffer. The first thing we're going to do is create it. Exactly the same. What's different about it is it's glue ints instead of GL floats. Yeah, that's different. Yeah. We made them up. We made these up. Yeah. This is telling it how to use that data. That's the difference. So we're going to have to make sure we tell the lovely graphics card that that's really what we want to do. Index buffer. That will be a bind, please. Thank you. We better allocate it. This is a special buffer, by the way. Soon as our graphics card knows it's an index buffer, and it does, because we told it here. Remember, I said I wanted to put these on so I could show you how it works. The vertex buffer, it doesn't know what you're going to put in there. The index buffer, it knows exactly what you're going to put in there. You're going to put in things that control this, that control the order of usage. So it already knows that. So that line isn't really required, is it? Is that? No, because we're not using it in our shaders. So what are we going to do? We don't use it in the shader because it's used to feed the data into our shader. So all we can really do is this line here. And that's it. We can't do the other two because that's to do with the shader. And luckily for us, the manufacturers of our graphics cards help us out by saying, oh, it's alright, don't worry about it, mate, we'll do it for you. Yeah, so it's allocate. There we go, there's our allocation. And it's index. Now, somebody might already be screaming, hold on a minute, you're using local variables here. Yeah, I am. Size of index. There we go. That's it. Alright, so we've got our vertex buffer object. I've made it a bit more complicated than I had to. I've done a vertex array object. For this size of a project, you really don't need to use all of this, but I just wanted to show how modern OpenGL works, that's all. Now, once we've recorded all of that, we can switch the vertex array object off. What does that do, Blades? It means that everything has been finalized and all our data is now on the graphics card for this array object. It makes sure that everything gets set up properly. So please remember to switch the damn thing off. Underscore test object, and it is release. There we go. End of file marker. We should also release, because we don't need them anymore, our position buffer. That can also be released because we don't want to keep the data here. It's on the graphics card. that completes that function. And of course the index buffer, don't need that either. Oh god, wait a minute. Do them in reverse, please. It's habit. I always do my releases in reverse, except for the array object that has to come first. Has to come first, and I do them in reverse. So that's a release as well. There we go. Lovely. And also, at this point, because we are finished with our shader program, we can also put m_shader program. Because we don't know, well, we do know in this case, but in normality, in a practical application, which this is actually, it's going to be a practical application very soon. In a larger practical application, you would have more than one shader. Trust me, we will have more than one shader. In fact, probably by the time we've finished this. So, m_shader program release. Okay, just cleaning up. That's all I'm doing. Just cleaning up. So I'll put that here. Clean up. Is clean up all one word? I don't know. Clean up and release the buffer memory. There we go. So that's released all our memory. Why am I doing that? Because we're going to hit this thing here. At this point, all of these, the M's aren't. The M's aren't destroyed, but verts and index are. This gets wiped out of our memory. Okay, so we don't hold the object in main memory, it's on the graphics card memory. And you find that when you buy a graphics card, it says, oh, I've got such and such memory. And there you go. And that's why. The more objects, well, the bigger the memory on the graphics card, the more objects you can hold, the more complicated the objects are you can hold. Right, do I need anything else here? I don't think I do. No, I don't. Okay. Let's try it. Here. Actually, wait a minute. Let's just run. Just do a build. Make sure I haven't made any typing mistakes in that lot. I don't think I have. How much have we added to this? Quite a bit. No, not a lot, really. I thought it'd be more. Okay. I have done something here. Yeah, I've been messing around with the resize, haven't I? That's irrelevant. Right. Right, I'm happy with that. I disagree with all of this lot, but hey ho, we've got to put it in because I haven't got a graphics card. And now you're starting to think, hold on a minute, you just sent all this to the graphics card and you haven't got one. Yeah, go figure. That's correct, I have. And I haven't got a graphics card. So it's gone somewhere. Virtual graphics card, maybe? I doubt it. It's actually gone into an interpreting program or storage or something. It's gone somewhere. I know it's not in the program. Put it that way. Right, let's see. How do we actually draw this? we would tell it which shader we're using. That's the first thing we would always do. Okay, if you remember here, I said it's going to record from here to that line there, because that's when we stop it. Nowhere in there have we told it which shader we are using. We have used a shader to enable things. It doesn't know which, so we have to tell it which. We could use a different shader now and really mess things up. So m underscore, this is why I needed these all as member variables. So m underscore shader program. And to switch it on, all we do is we bind it. That's it. Now to switch this lot on, this is ace. All we need to do is put m underscore test object bind, and we have now switched everything on, and it will use whatever the current shader program is for that bit. Okay, it knows about this, but it's recorded it in a very simple format. Which doesn't tell it which shader program we're using, so it'll just use whatever the current shader program is. Okay, so there we go, there's our test object. That's it. Okay. Draw, and we want elements. Has to be triangles. Can't take any other kind of data. So we're going to say, I don't know why you actually have to put this in, because it can't do anything else, as I found out. You have to actually tell it that it can't do anything else except for GL triangles, I suppose. What's the next number? Size I count. 1, 2, 3, 4, 5, 6, please. There you go. That was easy. What does it need next? Type. GL unsigned int. Yeah, I'm only looking at the index buffer because everything else has been covered. GL unsigned int. There we go. Const GL star void. Yeah, right. Start at the beginning and work your way through it. In other words, default, which is start at the beginning and use all of the data. So we'll start there and go through it that way. There we go. And that's all it needs. It knows to take them in threes. So I've just told it the total number, which has to be, obviously, divisible by 3 in this case. If that was 4, then that would have to be, yeah, it wouldn't work out. So it'd still be 6. Even if you changed that to 4s, your indexes wouldn't change. I could probably show you that. That's roughly about it, but don't forget, clean up. So after you've done that, reverse order m underscore test object, and again just release, and again to the shader program as well. Some people don't. I suppose you don't have to, technically, as long as you remember that you haven't. I mean, I could set that here, because I know this will run first, and then just GL draw elements and not bother releasing them. I could do that, but that wouldn't show you how it's working, That would just show you GeoDraw Elements is working. Let's see if that builds. There we go. There's my lovely square. Okay. It's in some kind of green. Did I program it for green? Oh God, I hope I didn't. Yes, I did. R, G, B. G is 80%. So yeah, 80% green, 20% red, 20% blue. And that shows that the shader is working. If you want to prove that your shader is working, all you have to do, let's put this one up to 80. What colour is that? R and G. Is that purple? Orange? I don't know. Save it out. And run the program. Oh, it's yellow. Oh, for God's sake, Muppet, get off me wire. It's attached to me headphones, love. That's me headphones you're pulling around. So that's yellow. Put that back to 20. This one will probably come out purple or something. B, I don't know. Put that up to 80. Save it or it doesn't work. Run. And that's light blue. Or light something anyway. Greeny blue. That doesn't look... Oh, it's because I got 20%. Yeah, that's right. A very wishy-washy light blue. Interesting fact. What would happen if I put that to 50%? That last number. This is where you find out, what does that last number do? Look at that colour. Because it's not obvious what it does. Let's turn this into 10. 10%. We'll go to the other end. I can't put 0, otherwise it'll be obvious what it does. There we go. Can you tell what it did? No? Okay. Let's put it to 0. I know what's happening. It does nothing. There you go. Does absolutely nothing. Why? Because our graphics card doesn't know what to do with that, so it does nothing. And that's the answer. We haven't told it what to do with that. We can, but I'm not going to in this thing because that's not what this is about. Right. That's our shader working. And that proves that it's working and it's working properly. That's fine, that's good. So what is this? Why have I gone to all of this extra curricular stuff just for a shade for this line here? Interesting. And the answer is, how do you test a shader? And that's the question you'd need to ask. The shader is responsible for a lot of your OpenGL. A lot. The data and the usage of the data, the recording. So what you do is you get your data all prepared, you record your data onto your card, and then you use that to draw the data. But it's your shader there that is actually involved in the draw. If you've got your data correct and in the right order, which I have here, and you've got your index and it's nice and simple. If I didn't want to use an index, by the way, I would have to repeat line 0 at the end. I hope that makes sense. That line there would have had to be repeated at the end. I would have to have had a fourth line. Or at least one more. No, we'd also have to repeat the 2. So 2 and 0. So that would be repeated. Then you'd have 3 and then you'd have 0. So you'd have 6. 6 lines of data. That takes 2 lines of data off. And if you save a little bit of data by using an index, then yeah, you should use an index. In fact, I always use an index because that's the way to go, man. No, that's because you save data, a lot of data, a lot of space. And that matters. That matters a lot. Because it also increases speed. If it isn't doing as much, it's faster. And that's what this is all about. Speed. And I'm going to ask the question now, how do we measure the speed of draw elements here? Because that's where your shader is actually run. On the graphics card, it runs on the graphics card here. This runs your shader. Okay? That's the command that does it. How fast is it? Interesting. Let's just go to the index. Well, how fast is it means you need to time it. What we're going to time. And I know what everybody's going to say. Oh, well, FPS, frames per second. How many frames per second are we getting? And that answer is completely and utterly wrong. Sorry, guys. But it is. I can't remember if there's a GL timer or not. Okay. Time list. Okay. There's timers, but time stamps. So these are the kind of time thingies we've got. Yes. Altimeter, basic timer, date, media, OpenGL time monitor. I've not looked at that. And timer query. Timer edit, timer, time zone. Right, let's put this in perspective. Let's just go back to the edit for a second. If you measure the frames per second, what are you measuring? Yes. I would like an answer to that. Anybody to answer it? No, not really. That's okay. I'll answer it for you. You are measuring the output of your graphics card. You are measuring what your a mechanical that your piece of hardware is outputting. It outputs in frames per second. You are not measuring anything to do with your program here. You are measuring the hardware. That's it. That's all you're doing. And your hardware is dependent on your monitor or television or whatever output display and your output card. And that hardware, you can measure its timings using frames per second or FPS. So what good is that to me? I want to know how fast my shader is, not how fast my graphics card is working. What we need is to know the time it takes to get from line 88 to line 92. So the end of line 88 to the beginning of line 92. We need to time that one draw call, and that's all. We don't want to know how many times it's been called. That's irrelevant. We want to know about this. So we could start a timer here, we could end a timer here, and then add times up, say for a second, and see how long we spend in there, in 1 second. And then if you take 1 second and divide it by the amount of time in here, you will know how fast per second your shader is. Drawing a very, very simple. How many times that shader can draw a simple square using this data per second. And that's the answer. So it is draws. How many times can you draw per second? So it's draws per second. Not frames per second. It's draw. It's shader passes, draw passes per second. You're going to get 60 FPS no matter what on this screen. I can tell you that straight away, without even going through the motions of timing it and showing you how to do FPS. That's pointless. What we need is a timer. And I'm interested in what's this time monitor here. Time taken to execute OpenGL commands between successive calls to record sample. Okay. That's the time monitor and query. Alright, this is a full timing thing for OpenGL. Fantastic. 3.3 and above. This is why I don't use anything below 3.3. Because 3.2, yeah, you've got to do that. 3.2 or less than. Yeah. ES2 and OpenGL 3 do not provide any support for OpenGL timer queries. Right, so we're not using it. I want cross-platform. Q timer class. We can start and stop a timer. I need really like a stopwatch, don't I? Can I set which type of timer it is? Oh, it's milliseconds, is it? Interval. What's that do? Holds the timeout interval in. I don't want timeouts. I just want a simple, very simple start and finish. Timer type, here we go. Course, you see, I'm glad I looked at this. See also Qt timer type. I thought that's what I was looking at. Ah, here we go. Precise timers try to keep milliseconds accuracy. So that's what we want. All right, let's attempt to make a timer. Let's attempt to make a timer. I think I'm overdoing this today slightly, but what the heck? Oh, forgot. Namespace Qt45 Daichi Baba. This is in core, isn't it? Yeah, this is all your timer formats. Okay. Timer class. Go back to top. Yeah, core. I think we've got core. We should have core. We usually have core. Core. Yes, we have. Okay. Let's go to here. Hash include QTimer. And let's make one. Call it stopwatch, I think. Why not? Got nothing to do with OpenGL, so I'm leaving a space. QTimer star. Interesting. Why a star? I am wondering. Well, I need multiple timers. Nah, not really. Stop. Watch. Okay, I think we can do this. So, let's set up our stopwatch. I'm not going to have it as a pointer. Why? Because it takes time to access outside memory. And I want the stopwatch to be in the fastest memory we can use, and that's the memory nearest the chip, which means do not put a star there. It's also not a massive, humongous thing that's going to clog up our CPU memory, so it's going to be fine. Right, let's set up our stopwatch then, shall we? Actually, no, I'm not going to put it after. I want that to be the last thing. Format used as I have no GFX card in this machine. Okay, that's that bit. Right, stopwatch. Stopwatch. Dot. Set timer type. It's Qt timer type. Okay, set timer type, and you put in Qt :: precise timer. There we go. That's all I want. How do we get output? If I start it, does it start from 0? Starts or restarts the timer with a timeout of duration milliseconds, right? Yeah. If the timer is already running, it will be stopped and restarted. Okay. Got you. So it restarts. Right. Slots. Right, okay. Now I just want to take a time. That's all I want. Remaining time. No, I want interval. How do you get the timer out of this? There is a different one, isn't there? Ah, wait a minute. I'm on queue timer. Alrighty, let's go to contents. I think there's 2. I think I'm on the wrong one. Alright, let's get the search going. Okie dokies. I think my coffee's cold now, isn't it, anyway? Oh well. That's fine. Okay. There is another one, I'm sure. Here we go. Oh, right. This one is clock time. Right. Okay. Yeah, so we're going to be using this one. Queue object. Handler in your class. I don't want to do that. Oh, God. Basic timer, timer event. I don't want events. That's the problem with this. It's an event system. It's Qt. And this, I just want a simple, you know, use a timer. Start and stop. I just want to do it with the beginning and the end of the process. Setting the interval of active. Yeah. Oh God, this is not going to work, is it? At all. I'm going to have to find a different way of doing it. That is a shame. I thought we could just read it. And this isn't. This is used for flow control. I would use this to call something like the draw call itself. I would have a timer going and just say every 10 milliseconds draw to the screen. That's how I would use this timer, because that's not going to give me anything. In process setting the interval. Change its timer ID, yeah. It's not going to work. Oh. And I don't want to use the C++ versioning. There's a way to do this. It's going to be simple. What I'm going to do is I'll sit down and think about it. There are complex methods of doing this, and there are simple methods of doing this, because the problem isn't how long does it take to do that. The problem is, how do we measure it without affecting the measurement? So I might have to put it with, I might have to slide it within I can't do that, that'd be naughty. Right. I mean, I could just set a timer going for 10,000 milliseconds. Yeah, what I'm going to probably end up doing is setting a timer going for a certain amount of time, a single shot timer, and then find out how far it got. I think that's going to be it. But I'll think about that because I don't like it. But I have now told you that the problems, yeah, there are problems in trying to do this. I think that's why it has an OpenGL timer, Qt OpenGL timers, because of the problems involved. I doubt they'll work on this system. I could try them. The easiest way to do it is to have a counter. Yeah. So what you would do is have int count. So, alright. Some kind of counter. Public and in here we would have a void reset count, and we'd also need a get count, wouldn't we? Yes, we would. And int get count, and that would just return count. Okay, so that's the two things we would have. That we will have to do here. Very, very simple. Underscore counter equals 0. And then all we would do is every time we go past our draw call, we would have I'll put it here, underscore counter plus plus semicolon, get rid. Right, yes. Now it's starting to come together. Lovely. It's pretty complicated to do it, but you've got to think outside of this object, because this object is just where I want the counter. It's got nothing to do with the actual measurement. What you then do, that's it, that's full programming for the counter. All I want to do is count how many times that line activates in 1 second. But that's the problem. I want 2 counters, don't I? I want 2 times. What this is going to do is give you FPS. Because it's measuring the whole, not here. I would need time 1. I need a time 1 here. A time 2 here. And plus equals timer time 2 minus time 1. That's what I need. We can reset the total whenever we want. That's what I need. What we've got at the moment is we need timers. I think that's the answer. My God, I've just realised what I'm doing. You're actually seeing me thinking my way through not a problem, but a result. This is how I work, and I do a lot of experimentation. This is why I prefer the research side to the development side. In development, I have to get accuracy. In research, I don't need to do this. I'd just give the FPS. So let's do FPS first, I suppose. Never mind. It's actually measured, not here. Which it may surprise you. That's all done. That's irrelevant now. Timer. I started a timer in here, didn't I, somewhere? You don't need it. No, we're not going to be using that. We'll just use a counter. That's all we need to use. So I didn't use it in here, did I? Yes, I did. I put the top somewhere. Yeah, it's in the wrong place. Alright. How would this be used? What you would do is you would set it up within your main program. Okay, so on shader display.h. Yikes, yeah, okay. Hash include Q timer. And it can go in here. It doesn't really matter if it's in what kind of memory it's in. Q timer. We'll just call it m_timer. That'll do. And that line that I put in goes into shader display CPP here. So it is m_timer dot set timer type, and it's qt t : precise timer. Okay. Go back to there, and we would now have void what can we call it? This is, it's giving it a name here, isn't it? Timer. I'm trying not to give it the proper name, because if I do, then I'm wrong in what I'm doing. Timer update. Okay, that'll do. Doesn't need anything. And we have a public, no, yeah, that's private slot, isn't it? Yeah, that's fine. Refactor, add definition in. Right, so these should be put on private slots. I haven't marked them. Yeah. Yeah, I'm push. Yeah, okay. Just not marked. Private slots. Okay, that should be right now. Right, we can do it with that. So here, right, it just restarts. Yeah, okay. Well, it should have stopped anyway by the time it gets here. So the last line of this is going to be timer start, isn't it? Hey, whoa, on those. Timer underscore timer dot start. Yeah, because stop is the receiver. Start can be a receiver as well. Okay, so no, that's all we're going to need. Right, we've got that bit. Now it's here. We have to go through the UI. So UI. Set up UI. No. That one. I can't remember if it's a dot or not. No. Reset count is what I put in. That's the end of the thing. Okay. It's going to count in what, though? This is going to be interesting. We're going to need somewhere to display it as well. Put it onto our display. That'd be great. Yeah, we can do that. Okay. So when it comes in, it's, well, no, I don't need to put it in there. I'm not putting that in. At this point, we want int interval. Oh no, it's count, isn't it? Int count equals UI display OGL get count. Okay. I could do with like a hash define or something here. A type def. Or a const. What can we have? I'm just going to put in a const. So const int no float no doesn't matter int. We've made everything ints, haven't we? Now it's not supposed to be. It's supposed to be floats. Float. 2 seconds. 2.0f. 2 seconds. Give it a name. Elapsed time. We'll do that. Alright. Yes, I'm making this up as I go along, don't you worry. Somewhere in here, we're going to have to connect it all up. So connect, and it's and mtimer. What is mtimer? queue time. It's the signal. Well, what is the signal? Signal. Timeout. Who gives that signal? That's a damn good question. Oh, I don't know. Signal. Open. Time. Out. No. QT, Q timer, come on. What are your signals? Signals, void, timeout. Oh yes, I think I know what I'm doing now. Edit, yep, okay, let's forget that. So Q, time, colon, signal would be timeout. There it is, the bomb. I don't need the brackets. Comma. And it's coming to this slot, which is shader display. Colon, and it's timer update. That one there. I don't need the two things at the end. Don't know why it keeps putting them on. Call to a non-static member function. Okay, so it's not QTimer. Well, I haven't set the timer to be this, so it's mTimer is an object. Call to non-static function. Timeout. I wonder if it uses the internal object. I bet it does. Alrighty, yeah, I know what I'm doing now. Yeah, Q object. We can parent it. Okay. That's fine. There we go, we've parented it. Well, we're going to anyway now. So here we need a comma, and it is m_time, timer equals a new Q timer, open brackets, and this. Okay. There we go. Set the timer. It isn't Q timer anymore, it's this. We can't do that. Shader display. Doesn't have a timeout. Doesn't make itself obvious, does it? It's a meta object. The way I've normally done it is signal, open brackets, timeout. That's that. Oh god, do I need to set an interval or something on this? And this would be to signal and slot. And it's happy now. Okay. It's worked it out for me. I don't know how it's worked that out, and I've forgotten. It's Q timer. How weird. Right. So now we've got that, we can now start it. And what we do is we take the timer, and we start it. Whoops. Start and milliseconds value. 1, no, 2. 1, 2, 3. I think it's 2000. What's 16 times 60? 1,000 ish. Yeah, I think that's right. He's purring. Oh, Muppet's purring at me. Alright. So when that timeout comes off, it has to be the same. Yeah, okay. There we go. Int count equals that. We then reset the count. And all we need to do is display it. That's it. So display. I did set up the other thing, didn't I? The elapsed time. I'm hoping for 2 seconds. And that's got to be a float. That gives back an int. Static cast to float. That's you lot. That's now correct. And we need somewhere to put it. So float result. Do this equals count divided by elapsed time. That is correct. Where do we put the result? Alright, we need to put it somewhere. Okie dokies. Move that close button over here, I think. Just for now, because, well, we need a display, don't we? Display widgets, here we go. Oh. Well, that's a display widget. Can I give it a different palette? Let's pop it in at orange. Something bright. There we go. So that is going to be our result box. It's a QLCD number. I have no idea how much information this is going to give. Give it some space. And it comes under QLCD number. Alrighty. So this is going to be our... what should we call it? Counter. Yep. Counter. Will do fine. So that's where we want to output it to. Right, I'm going to have to work this out now, aren't I? QLCD number. Alrighty. LCD number. Here we go. Int value. Void display int number. Okay. It is an int. Basket case. Set a function for property value. Use double. Oh, it's overloaded, is it? Double. Why double? Okay. Eek. Double, please. Implicit conversion, yeah, no, I'm going to fix you now. There we go. There we go, it's now a double. There it goes. Right, so now we have to display it. Yeah. So it's going to be UI. Counter. Oh, it hasn't come up yet. Alright. Yeah, we can't do it yet. Just make sure we haven't oogered it all up. There it is, there's our counter. It's nice and in orange and it says 0. That's fine. Okay. Make sure it's there. It is. So, we are going to use UI. Counter, there it is. And that's going to be display our result. Okay. Nothing. Our result. Oh, wait a minute. Oh, no. Yeah, we're getting nothing. It did do a 1.15 for a second there, but I don't know what it's actually trying to output here, so close that a minute. It is working. So every 2,000. Ooh, that is a small amount. We are getting the count and we're dividing it by 2. Or halving it. Which is a bad idea. The UI counter then displays it in some format or other. No idea. Then we reset the count and start the timer again. And I don't think it should be displaying anything. Right. I don't think it should be displaying anything because we're not actually doing anything. Or I haven't asked it to do anything. What I'm going to do now is I'm going to do something a little bit dodgy. Because I shouldn't do it here. Alright, let's do it here. We know all of this is working, so that's okay. All I'm going to do is ask it to come straight back and do this again. We've got this counter going on, haven't we? Yeah. So this. Don't need to. Just put update. So all I'm going to put, and that will then lock it into this. The timer will do an interrupt. There it goes. Now it's working. Yeah, that's the FPS. Are you used to getting FPSs of 1,335 with no graphics card? Yeah, it's right. Whoops, sorry. Yeah, that is the actual FPS that this is being drawn at. So it drops if I move the window. If I carry on moving the window around, it drops. If I get hold of this, what will it do? Oh, look at that. 455. So 445. 300. Can I get it any lower? 275. That proves that that is the FPS. You can see it climbing back up now as it settles down to its new size. But now I've got, yeah, it's climbed back up to 1,200. That is amazing. So yeah, that is the FPS. That is useless to me because that is measuring how many frames per second we are drawing to the screen, which is basically the output of the OpenGL system to that box. So if you ever wanted to know how useless FPS was, that is useless to me. How many times can I draw that per second is not that. It's a lot larger than that. It's probably 10 times that. Hundred times that even. So I'd need a timer in milliseconds, 1 divided by 1,000. In ms divided by 1,000. We now found out it's a double. Hey, Muppet. You alright? Hey, babe. That's a nasty cough you've got there. So it's double. So I think we've constructed it. In ms divided by 1,000. And then we can do time 2 and time 1. M counter has to become a double. So there we go. You're still running. Close. So we know now that it's a double. That's okay. Which means we can now double that. There we go. Don't need to correct anything in here. Yep, that's okay. Yeah, we should do that as well. Oh, we can't because we're on a simple shader. I remember now. That's why I haven't put it in. That's okay. Alright, so that's altered. That should be okay now. So I've got everything now as a double. That's fine now. Yeah. Right, so that is the answer to your FPS problem. The reason why it's 0 for 2 seconds is because there's no reading. There you go. Just see if I can get a... Right, there's no output. Oops. There we go. That is today's lesson in how not to measure time, or how not to measure the efficiency of your shader. That shader plus that program, I mean, if you kept the program exactly the same, which you can't, because we have to modify the program for the next shader. So I could take this as a base value, but that would be FPS. The final calculation there, by the way, is incorrect. Because we're not storing a result. That should be an average. So to smooth that number out, we would use underscore result. And there's a big difference. I'm just basically showing you how you can actually tinker with this to make it work better as an FPS counter, which I don't know why I'm doing that. Result. Bad word for a variable, but it will do for this test. I wouldn't choose m_result ever as a member variable. I think it's a bit dodgy and very vague. What you do, mResult equals plus equals. And then m_result has to be, we've now got two results, so it is now times 0.5. And it's not 0.5 f. Oh, it's just times equals, isn't it? That should give me the final one. It won't work without an initial value. You'll have a 0. I give it an initial value, just to give it something, for a calculation in case it needs it. So we can start it at 1. So you'll have to let it warm up about 2 to 4 seconds. And that will give you a better average. It should settle down over time. But the more results you can put in there, and the more averages you can take, the better. So you could store, say, the first 10 results. So you can actually put this into like storage and do a vector pop back. That's better. So 1100 is the answer. Although it still likes to pop up every now and again when I stop using the mouse to 1.3. Wow. Oh god, we're past time as well. Whoops. We're into overtime. So that's really as far as I'm going to go today. Yeah. You have an FPS counter now on your shader. Is that useful? Probably not. But it will show if a shader's working harder. Oh, by the way, if yours is showing 60, it's because your graphics card is locked to 60 frames per second. So it's another way of checking. If that just says 60, dead, then yeah, your graphics card is locked to the V-Sync, probably, of your monitor. 1, I've got no monitor. No, 2, I've got no V-Sync. And 3, I've got no graphics card. So that's the fastest that this virtual machine can do this. So if your machine can't beat 1300, then you got problems. You can see how much the mouse is affecting it. I mean, that's just capturing the mouse in here and outside. Oh god, I've done that now. Just doing things like that. It's quite amazing, the differences. How you can spam that down so far. Right. We've talked about it. We've said this isn't correct. Is it a valid? No. Can you use it to gauge performance? Possibly. If you can unlock the manufacturer's settings, then yeah, go ahead, use it if you want. I mean, I can use it, so I might not go on to do a timer. And if I do, I can just put it on another thing, can't I? Yeah, okay, I'm happy. It shows you how easy it is to do your GUI and how rubbish Microsoft's is compared to what you can get just by doing virtually nothing. I mean, I just threw that up onto the screen very happily. But I'm not working on that. I want to work on that. So that's the kind of thing that you're looking at there. That's the answers. By gum, it's come to that time of day when I've got to press some buttons. Normally I'd have some music for you. Where is me music anyway? Hey, music, come back here. Come here. Aren't you in here somewhere? Yeah, you are. You're there. There we go. So yeah, it's nice. It's coming along nicely, this. And I am starting to get this together for next week. I'm going to be using all of this. I'm going to be making some files to go in there. And we're going to start storing files in there, which is going to be interesting. In the meantime, we're going on to Friday next, aren't we? Well, on Friday, I probably want to start looking at other shaders. I'm not too bothered about measurements and stuff at the moment, because that was an example and a talk about how you should think about these things rather than what I wanted to do. I wanted to show you more of the boundaries and the places you can go with these things rather than just, oh, this is the code, this is what it is and has to be. It doesn't. Play with it. Do it differently, for God's sake. Stop this, oh, it's good enough syndrome that programming has become. Start breaking the boundaries, eh? That'd be nice. That'd be really nice. Take care, peeps, and have fun.